293. 293. All right, so yesterday we were looking at exponential functions in terms of the reflections and how we could determine if a new graph would be growth or decay. We're going to do a little bit more with that today, but our goal eventually by the end of this unit is to be able to just look at a graph and figure out the equation. Okay, what would the equation of that exponential function be? So we're going to kind of baby steps today, talk about how we can do that. Can we figure out if A is positive or negative? Can we figure out if B is greater than 1 or in between 0 and 1? So we'll eventually get to figuring out the actual number values, but let's first start to think about ways we can look at this graph to pick apart different characteristics. So taking a look at this first graph, they give you the basic equation of this graph. Okay, I would first take a note that they are automatically telling you that we have a negative in the power spot. Okay, pay close attention to the information they give you. What type of reflection would that be? A y-axis. Good. Okay, so we definitely know that there was a y-axis flip done to a graph. All right, let's check out some of these different characteristics we can pick apart from this graph. Is the graph provided growth or decay? Okay, Kyle? Because? Moves away from horizontal asymptote to the right. I like it. All right, what about the end behavior? If you were to trace the graph to the left or trace the graph to the right, how would you describe what it's doing? Does it go up forever, down forever? Does it do something completely different? Yeah.
The left-hand behavior is going towards 2.
Okay, so the y values, the height of the graph approaches 2. I like it. What about the right side? The y values or the height approach if you were to keep tracing the right-hand side, go to Summer? Negative infinity. Perfect. Okay. Based off the graph, can you find where the horizontal asymptote is located? What height or y value? Go ahead, Summer. 2. Looks good. Okay. Are we hanging in there? Different characteristics? Okay. Now, based off the way this graph looks, we're going to try to figure out what kind of numbers A, B, and C might be. I think for us, the easiest one to determine is probably going to be this number being added or subtracted on the end. Based off the way that graph looks, do we already know what that number is? What do you think? I saw you shake your head. Not to put you on the spot. But
It's like a little more than 1.5.
it's actually going to be 2. So 2 is a little bit more than 1.5. It's where your asymptote is located. So we already know the C value is 2 because of that horizontal asymptote. Good. All right. Let's maybe check out the A value. Now the A value is this number out front. For now, we're just going to try to determine if that number out front is a positive number or a negative number. Okay? Now, based off the way this graph looks, what do you think the A value might be? Positive or negative? You kind of have a 50-50 shot. What do you think, Kyle?
Negative.
Why?
Since it's below the asymptote.
Okay. So if you think about exponential functions, we'll say negative because it's below the asymptote. When you think about exponential functions, you only have 2 options. You either have growth or decay. Now what I'm going to do is kind of slide this paper over the notes just for a second. Okay? For your parent graphs, you either have exponential growth or exponential decay. Do you notice how for either one of those they're both above the asymptote? Okay? But in the graph provided to us, it's below the asymptote. So if you want to go from above the asymptote to below, you have to do some type of flip. Okay, an upside down flip. And that's indicative of an x-axis reflection, meaning we would need a negative on the outside, okay, where that a value is located. So we know a must be negative since it was flipped, meaning it's underneath or below that horizontal asymptote. Does that make sense? Okay, we started from above, but now it's below, so we had to flip it, meaning we need a negative out front. Okay? What I think is going to take us a little bit of time to try to get used to is figuring out this b value or the base. So what we're going to have to analyze, like we did yesterday, is these reflections or flips that are going on and what we started with in order to give us this resulting graph that was provided. So again, you only have two options. You either have growth or decay. Okay? Now what kind of flips did we have labeled for this example? Yeah.
Y-axis.
We definitely have y-axis because we had the negative out front. Did we identify an x-axis flip as well? Didn't we say the a value had to be negative? Okay, there's a negative out front. So we have both flips. So I want you to ask yourself, if these are the only two beginning options and you were to apply both flips to both of these, which one would eventually look like this? That's what we're going to try to figure out. Okay? So let's maybe try the growth option. If we were to apply both flips, x-axis would flip it upside down, and then y-axis would flip it left and right. Does that black graph look like the one that we're analyzing? No. Okay, let's try the next one. If we were to flip the decay upside down, it would look like that. And if we flip it left and right, it would look like that. Does that black graph look like the one we're paying a close attention to? Okay, so notice how the beginning parent graph was decay. So what must the b value be? Is it greater than 1 or in between 0 and 1? What do you think, Kyle? It's between 0 and 1. Okay, we started with decay, we applied those flips, and this is the graph that we have left. Okay, so we'll say b is between 0 and 1 because we had two reflections, or both reflections. That's just our justification for this example. Okay, it might not always be because we had two reflections. This is just for the one we're working with right now. Okay, so I think the C value for us is going to be really easy. I think the A value for us will be pretty easy. It's the B value that we might have to do a little thinking about. Okay, let's try the next one. Okay, pay close attention to the equation they give you. Looking at that graph right now, is it growth or decay? Decay, why? All right, towards the asymptote, to the right. Good. All right, left and right end behavior. As you trace the graph to the left and to the right, how would you describe what it's doing? We're particularly looking at the y values, aka the heights. Addison, yeah? There we go, left-hand side goes up. -1, perfect. All right, and since we are approaching -1, that's our asymptote value that we're getting closer and closer to, but never actually touching or crossing. Looks good. All right, what do you want to tackle first, A, B, or C? B? We like the B value? Let's try B. Okay. Well, before we tackle B, we should probably tackle A, because in order to figure out B, you have to analyze any flips or reflections. So let's first figure out if A was negative or not. Okay, and then once we know that, we can figure out B. So let's go ahead and try A first. That number out front, positive or negative? I heard positive, good. Because? Yeah. It's above the horizontal asymptote. Yep. Which means we did not flip it upside down, so there's no x-axis flip. Okay? Let's now maybe go ahead and tackle B. Even though we don't have an x-axis flip, is there a y-axis? Yes, it's kind of hidden. They gave it to us in the equation. Okay? So we got to ask ourselves, if these are the only two beginning options, which one can we flip left and right, okay, y-axis flip, that would eventually look like this graph? Growth, right? If we flip the growth left and right, it would change to decay. So the original parent function was growth, which means our B value is bigger than 1. Good. B is bigger than 1. We'll say because of the y-axis flip for this particular example. All right, and last but not least, our C value. That number being added or subtracted on the end. Yeah, Kyle? Because? That's where it's located. Pretty darn good. Do you guys think you can try the last one? Pick it apart? All right, pay close attention to the equation they give you. How do we do on the first 4 characteristics? Pretty good? All right. Any takers for A, B, or C? Let's not all jump at once. Yeah.
A is positive, so it's above the horizontal asymptote.
Okay. How did we do for A? Good? Okay, any takers for B or C? Yeah. Okay.
B is greater than 1 because there is no flip.
All right. So, there was no negative in the power position, we just identified that there was no negative out front, so there's no flips whatsoever. So this graph was never changed. So if you look at the graph right now, it's growth. So the B value must be bigger than 1. I love it. What about our C value? Easy peasy. Yeah? Because it's the horizontal asymptote. Perfect. All right, so what we're going to do, seems like we're doing no trouble with those. We're going to try to answer the same questions, but instead of dealing with a graph, looking at a picture, we're going to look at a table of values. Okay, how can we still try to figure out A, B, and C just with a different piece of information given to us? So let's pay close attention to the equation at the top, just like we did on the other 3 examples. I'm not sure if it's hard to see or not, but there is a little negative up there, so we do have to be careful with a y-axis flip. That might come in handy later. Okay, so based off the table, take a look at the numbers. Do you think this table would represent exponential growth or decay? If you have to, maybe draw a rough graph with those data points. If you need a picture, try that out. Maybe we'll do that at the bottom. Let's see, at -9, we have a really high value, but at +9, it's like we're getting closer and closer to 1. So it probably looks something like that. Growth or decay? Good, Summer? Decay, how'd you know?
As it goes to the right, it approaches the horizontal asymptote.
There you go, because to the right, the values approach a horizontal asymptote. Good. What about the end behaviors, to the left or to the right? Let's see, if you trace the left-hand side of the table, what are the y values doing? Yeah. They're getting closer to infinity, all right, so we're going up forever. What about the right-handed side? If you travel to the right, what are the y values doing? Good, Kyle? Approaching 1. All right, so this value of 1 that we're approaching must be our horizontal asymptote. It says give a reason. Maybe we'll say because of the right end behavior, we were approaching 1. All right. Let's try tackle A, B, and C now. So based off the table, what do you think that number out front might be? Positive or negative? How'd you know? Good, Mario? Okay, so graphically, you can see that it's above the horizontal asymptote, but let's say you didn't draw that graph, okay, you're just going based off the table. How would you still know it's above the asymptote? Yeah, it's all the way up to 500. We said that the horizontal asymptote was at 1, and if you look at all of these y values, aren't they all bigger than 1, meaning above the asymptote? Okay, so positive because above horizontal asymptote. All right, let's tackle the B value. So we got to figure out, were there any flips done that would have changed the parent graph? We identified a y-axis flip from the equation. Do we have an x-axis flip? No, because we said that number out front was positive. Okay, So out of your two options, which one can you flip left and right that would look like this graph? Did we start with growth and flip it left and right, or did we start with decay and flip it left and right? Growth, yep, because if we flip it, it'll match the graph we have for this problem. So if we started with growth, the b value must be bigger than 1. And for this example, we'll say because of the y-axis flip we had to apply. Alright, what about the c value, the number being added or subtracted on the end? Good, Kyle? 1 because? That's your horizontal asymptote. Perfect. How are we doing with the table? Still okay with the graphs? Okay. Let's check out domain and range. Little throwback. We have a graph down here which is nice. So if you were to trace the graph left to right with your pencil, where would you start? Where would you end? How far left and right can you go? Do you have any holes or asymptotes or jumps you got to worry about? Vertical asymptotes, that is. No, right? So our domain would be negative infinity to positive infinity. We can go all the way to the left and all the way to the right. What about the range? That's the low to high. When does your graph kind of start? At what height? What do you think, Kyle? Can you touch 1? No, so we would need a parenthesis and goes to infinity. Perfect. We doing okay? Alright, so that's it for this section, but we're going to skip over to the next one, which is on page 299. So this isn't really going to be anything new, it's just that we are now going to officially try to figure out what is the a value exactly, like the number value. What is the b value exactly? So we're going to bring all that information together so that we can write the equation of these different exponential graphs. Okay, so on page 299, let's check out this first one. They give us the graph, which is great, and they give us the form of the equation that we should be using. All right, now for the first one, I give you some type of steps to help you figure out what the equation is, but notice how for the next example, I don't number it 1, 2, 3. Okay, this is just for us to kind of get used to it. In the end, we're going to try to do all of this just for one problem. Okay, so personally, and I think for you guys too, the c value or whatever is being added or subtracted on the end is the easiest one to figure out first. Can we figure out what the c value is based off the graph? C value is, I need like Jeopardy music. Go ahead, Summer.
Negative.
-3. All right, so because, how'd you know? Sorry, how'd you know? It's the horizontal asymptote. Okay, so what I would do is as soon as you figure out what a letter is, okay, what that number for the letter is, I would rewrite the equation. So we're going to do that kind of down here. F of x equals a times b to the x plus 1 power, and we need a -3 on the end. All right, let's check out number 2. We already rewrote the equation. Then use, you can cross out that word find, little typo, use f of -1 equals -2 to find the value of a. So what's that telling us? What's that -1 represent? What's that -2 represent? How can we use those to find a? Do you remember our function notation? Good, Kyle?
F of 1 tells us, or F of -1 tells us that -1 is the x value.
Okay.
And for that x value, -2 is y value.
is a y value. Yep. So graphically, if you look at your picture here, if you go to -1 on the x and -2 on the y, this is the particular point that we're using. So if we were to plug in -1 for the x variable and -2 for the y variable, somehow we should be able to figure out what a is. So let's simplify and kind of see what happens here. In the power position, we have -1 plus 1, which is just 0. What's b to the 0 power? 1. Anything to the 0 power is 1. So this is essentially a times 1. The b is going away, which means we should be able to figure out what a is. Looks like we get 1. Alright, so we figured out another letter. Let's rewrite the equation again. F of x equals 1 times b to the x plus 1 power, and then we have a -3 on the end. Why do you think they wanted us to use this specific point to help us figure out the a value? Why not choose another point? What do you think, Mario? It is an actual point, okay, but I'm curious, as this is an actual point as well. Why did we have to use this one and not that one, or even this one up here? What do you think, Kyle? It makes the exponent 0. Okay, notice how in the exponent spot we had a +1, so we would have to throw in an x value of -1 to cancel it out. That way when we get a power of 0, that variable is going to go away because it's essentially 1. So that point is really special. Okay, we eventually have to figure out what can we plug in there to get a power of 0 to get rid of that b. Okay, so that's why that point is special. But notice how we have one more letter to figure out. Okay, we got to figure out what b is. This is when you have a little bit more freedom. So why don't we go ahead and pick another point on the graph to plug in for x and y like we did before, and it'll help us figure out b. So can you find another point on here that you guys would feel comfortable using to substitute in? Another easy point? You could use 0, -1, you could use 1, 1, you could use 2, 5. You have a bunch of options, okay? I like 0, -1. What if we use 1, 1? That way they're both positive. Is that okay? You could use the negative. You could use a negative. It would still work out. You just might have a little bit more to do. Okay? So let's maybe say we'll use the point 1, 1. Let's plug in 1 for the y position and 1 for the x. And let's solve for b. So we have 1 equals b squared minus 3. Add the 3 over, we'll get 4. So what's our value for b? What do you think, Kyle? 2. Okay. Why is it 2 and not -2? Kind of. Okay. Do we realize to get rid of that power of 2, you have to square root both sides? And whenever you square root both sides, you need a plus or minus. Okay? So when you go through the solving process, you'll get plus or minus 2. But if you think about what type of number b should be, isn't b either between 0 and 1 or greater than 1? Right? -2 doesn't fit in either of those options. Okay, so b would have to be the positive 2 result. So we figured out c, we figured out a, we figured out b. We're going to bring all those together to write the final equation for f of x. So we'll have 1 times 2 to the x plus 1 power minus 3. Now, if you don't want to write the 1 out front, you don't have to, because multiplying by 1 doesn't really change anything. Okay? We're going to try another one without kind of the steps listed. Let's check out the next graph. Okay? Let's pay close attention to the equation that we're going to use for our formatting or our solving. Okay. What do you want to figure out first, A, B, or C? Which one's a little bit easier for us to pick out? Or C? Okay, what's our value for C?
4.
We got 4. All right. So let's go ahead and rewrite the equation. We figured out what a letter was. All right. Let's go ahead and try to figure out A. In order to figure out A, we got to somehow get the power to be 0. That way the B value would go away. So can you find a point on your graph that would turn that power position to 0? What point should we use? Yeah? 0, 2. All right. So 2 is a y value, 0 is the x value. Notice how that makes the power 0, so the b is going to go away. And we're left with a plus 4. So our a value looks like -2. Let's go ahead and rewrite the equation. G of x equals -2 times b to the x plus 4. Now the second point we pick could be anything. Can you find another nice point on that graph that might be useful? What do you think, Kyle? 1, 3. I like that because both numbers are positive. You also could have used -2, -4, but both of those are negative. Could be a little trickier. Let's go ahead and use 1, 3. Okay, so 3 is a y value. 1 is the x value. What's b to the first power? Just b, yep. Alright, so solving for b, we can subtract the 4, divide the -2. How does 1/2 sound? Good? Alright, let's put it all together. Final equation, g of x equals -2 times 1/2 to the x power plus 4. We doing okay? Alright, let's actually make sure that these numbers make sense, because maybe you're going through the solving process, you're on a roll, okay, and your partner, if this was a partner quiz, was like, are you sure? Like, is that right? How can we check it? Okay, so we're particularly going to take a look at the values of A and B. Do they make sense? I think the C value is really easy for us to determine. The other two can be a little tricky. So does this A value of -2 make sense for the graph that they provided? What do you think? Did we do good, or are we completely off? What do you think, Kyle?
I said matches because it's below the
There we go. Yes, because the graph is below the horizontal asymptote. Okay, that graphical characteristic only tells us if the A value should be negative. Okay, it doesn't really specify -2, but at least we knew, or we know we're on the right track. We got a negative value, so it most likely makes sense. Okay, what about the B value of 1/2? Does that make sense for this graph that we started with? Why? It's decay, okay? Now, this graph is decay right now, okay? But what was the graph before? Let me bring up the paper. Remember, these are our only options, okay? Growth or decay. These are the only options. Did we identify any flips in this equation that we have? Do we have a negative somewhere? Out front, right? Which is an x-axis flip. So if you were to flip this growth graph upside down, it would look like that. And if you were to flip the decay graph upside down, it would look like that. Which one in the end looks like the graph we want? The decay, okay? So we're not basing it off of the fact that this graph is decay. We need to base it off the fact that the beginning graph we had was decay before we had all those different flips, okay? So yes, because the x-axis flip caused the parent decay graph to flip upside down. Okay, you can write whatever you want to there. That's just some explanation to determine that the B value was on the right track. We hanging in there? Pretty good? All right. We'll stop there for today. Bell's going to ring in a little bit. We're going to do a bunch more of these tomorrow, but we're also going to take a look at graphing calculators tomorrow. How can we use, or how we can use those to help us write some functions. So if you can remember tomorrow to grab one, that would be great. Okay?